bless you, journeyman. It's Abuela again. Week 22 of our science. Okay, today we're going to be talking about catapults, and I made a couple. It was really fun. Okay, so I'm going to show you a picture of the catapult first. Okay, and then we'll discuss it. Okay, these are some catapults. Okay, and here's one made with a spoon. Here's another one with a cat. Okay, and here's some other ones. Okay, these are the ones that I made. All right. Now here, you see here, there's the bucket, okay, where you put the mass in. Okay, the weight is the mass, and the lever is right there. That's what you press for it to go forward. This is the force, and this is the spring, and the force and the spring are made with rubber bands, in our case. This is the frame, okay? And then there's something called a fulcrum right in the middle, and that makes this move up and down, okay? And of course there's wheels, and there's all sorts of catapults that you can make, okay? And again, you can find this at CC Connected. You can download it, okay? All right. So let's take a look. So, remember week 16, 17, 18, and 15. I did it that way. So we're going to recap on those weeks real quick. Newton's first law of motion states that an object at rest tends to remain at rest, and an object in motion tends to continue moving in a straight line at constant speed unless an outside force acts upon it. Okay, like remember, well, you can think of something going this, straight, and then this is going straight, right? It's going, but then, if I hit it, it moves out of space. Newton's second law of motion states that force equals mass times acceleration. F equals ma. Remember what I said a couple of weeks ago? Whenever you have two letters together like that, it means to multiply. So that's what the mass multiplied by acceleration. That's what force equals. Okay. Newton's third law of motion states that for every action there is an equal and opposite reaction. Remember that? Just like when we were doing the bridge, okay? So the bridge is this way, and then when the weight is going down, there's something in the bottom that's going up. So it holds the bridge up, okay? All right, so your catapult is what you're going to be making. Physicist is a group of people who study the math and the science on motion. Study motion and the math needed to calculate how to convert potential energy into kinetic energy. Remember that? I have this stick in my hand. It has the potential to fall, but it's not falling because I'm holding it. But if I let go, that potential energy just turns into kinetic energy. You're right. Okay. So, how fast and far a projectile will go is based on its mass and force applied. So what's a projectile? A projectile is anything that's going to be thrown. Like over here, I have a little red fuzzy ball, and we're going to be projecting that in a little bit. Okay? So, based on mass and force applied, and that's Newton's second law of motion, F equals ma. Okay, the outside forces of the air, resistance, and gravity, it slows it down. Newton's first law of motion, right? That's what we saw up here, right? So what does that mean? Well, when we catapult, because we give it that force, that push, it's going to go like up. But then what happens? The gravity and the air is going to slow it down, and eventually what you projectile is going to come down. Okay? And back then, when they did their catapults, it was used for war. So they kind of like was doing the science, figuring out where that boulder, when they threw it, was going to hit. A lot of times it hit ships and wherever else they wanted it, and it did. It landed. Okay, so there are many different types of catapults. They have been used over history. The Trichbisha and the ballista, they're huge. Both of these are huge. And we don't need to build a big catapult because who are we going to bomb? We're not going to be bombing our neighbors, right? No. Okay, so, and when you make your catapult, you got to make sure to use softer things so not to hurt your brothers or sisters. Okay? All right. So, yeah, so the trebuchet and the ballista were famous in the Middle Ages. Each catapult needs force and energy to get your projectiles flying into the air. Okay, that's the science of physics. The science of physics, making them go. Okay, or movement. As you pulled back on your catapult, making it ready to launch, potential energy was being stored up. It was stored up. Then that tension created in the rubber bands built up the potential energy and force that you needed. So what's going to happen when you let it go? When you let it go, you release the potential energy, right? And it transformed into kinetic energy or movement. Okay, and I have one here. This is one of my inventions. Oh, over here, you can decorate it too if you want before putting it together. Over here I put Jesus catapulted my life, because he sure did. Okay, so over here, what I did, I didn't have the glue to glue the cap, so what I did, I made two little slits on both sides, and then I just rubber banded, okay? So I'm going to put this little thing here, and let's see. You ready? Here it comes. And there it is. Okay. So this is what that's talking about. So different catapults will launch projectiles different distances depending on how much energy you can build up. Other factors could be mass or weight of your item. So we're not going to put a rock in here, or else it'll go even further, but I don't want to hurt anybody or break anything. Okay. So, and the aerodynamics of your object, it's how well it's made, like the airplanes. Remember aerodynamics with the airplane? Okay. And certain airplanes, it went further than others. Okay, so if you had more of a pointy type of a boulder, that probably would have gone even further than a round or squared boulder. Okay, so in the air, it's the force of gravity and air resistance that slow down your projectile. Remember that? So it's the force and the gravity of the air. Remember those air molecules? That's what they're talking about. Okay? Resistance, it will slow down those things that are being thrown. Causing it to arc and land. Arc and land. Before cannons were built, catapults were the most effective launching machines. Yes, a catapult is a type of machine. And I drew a little picture here. It's the same thing as this. Okay? And I even did one with a spoon. Okay? It's so easy to make. I'm going to show you. Okay. So here I have some sticks. 5 sticks I chose. Okay. I usually put 2 rubber bands, so this way it's a little better here. So here we go. Oops. 5 or 6 times for that piece, for the 5. Then I take another one, 2 more, put it together, and again 2 rubber bands, 2, 3, 4, 5, 6, that's fine, and then 6 on the other side, 1, 2, 3, 4, 5, 6 on that Oops, I forgot. I only needed it on one side. I forgot. This has to go like this. It has to open. Okay. Oops, here we go. Okay, so now I made my cross, and now I'm going to put rubber bands to hold it. And again, 2 rubber bands on either side. 1, 2, 3, oh boy, 4. Okay, so now let's do the other side. See how it is? Now I'm going to cross it on the other side. So I'm going to move my hand a little bit here. 1, 2, okay, 3. All right, and there you have it. And there's your catapult. And again, you could put the cap. Okay, and let's see. Even though I don't have a cup to hold it, let's see how it works. I don't know where it went. It went somewhere. All right, and there you have it, okay? So have fun making your catapult. Very easy to make, okay? And just do me a favor. Don't be shooting your brothers or sisters at anyone else, okay? Use softer material. Thank you. God bless you, and have fun with it. I love you all. God bless.